Hi everyone, thank you for tuning in. This time I'm going to talk about one of the projects that I have worked on, which is car prices prediction. And in this car prices prediction, we are going to basically take into account a lot of features. And then finally, after taking those features, we are going to be predicting the actual car price. We have a history of the car prices data, and we have a large amount of data, and we take that data, and then based on that we try to predict what can be the new car price based on the features. And when we look at some of the performance metrics or business constraints, we see that the car price is actually depending on a few features like what is the mileage of the car, or what is the size of the car, or who is the manufacturer. It can be either we have Bugatti or we do have normal companies. And when taking a look at all of these, we try to predict what can be the future price of the car. And this is the data which was taken from this particular link. And we are actually looking at machine learning and deep learning in this repository. And also, it's important to evaluate how our machine learning model has been doing in the test data. And in order to just perform machine learning, we always first train the model, which is the first step, and then we also divide the overall data into training and the testing part. When we take the test set, we take the test set and then we try to evaluate how each of our models are performing based on their training. If they perform really well on the test step, it means that we are doing a good job. And in machine learning, the first step is to perform exploratory data analysis, where we try to identify interesting trends and patterns in the data. And after taking a look at the interesting patterns, we also try to implement some machine learning and deep learning models. And in this list of tables, I have added some features or some metrics like the mean absolute error and mean squared error. And these are all some machine learning models that I have used. And let us now go over the code so that I can explain everything in great detail. And we see here in the introduction about the useful use case of our machine learning in predicting the car prices. We have taken a few metrics. This is the source of the data. And here we do find the table of contents, which talks about the introduction, source, importing the libraries. We also take into account exploratory data analysis, which is nothing but exploring our data to find out hidden trends or patterns in the data. And when after performing that, we'll also do manipulation of the data, such as we'll shuffle the data and we'll divide the overall data into training and testing parts. And then we'll also be encoding the data so that if we have something like a categorical feature, we try to convert all of those categorical features into numerical vectors so that our machine learning models can actually make predictions from numbers. And these are all some machine learning models that I have used. And finally, here is the summary result with all of the bar plots, which contains the mean absolute error and also the mean squared error. These are some of the libraries that I have used in the beginning, and we do the exploratory data analysis to find out the total car companies with their cars, and we see that in our data, we do have a large number of cars from the manufacturer Chevrolet, followed by the one from Ford, and followed by Volkswagen and few others. And when we look at the total number of cars based on the years, we find that we have a large number of cars in the year 2015 compared to 2016 or 2017. Therefore, when we are trying to predict based on this data, our models can most probably have information about the cars which are manufactured in 2015, and they should be able to predict quite well. And similarly, we look at the transmission type in our data set, and we see that most of the cars are automatic, followed by manual. Similarly, we also take a look at the engine fuel type, and we tend to see that most of them are regular unleaded. And we take a look at the count plot, and then here we also see that most of them are compact, and there are very few uh, cars which are large in size in our data set. Therefore, most of the cars fall in the range of compact category, and it is always important when we are taking a data that it should not contain any missing values. If we have missing values in our data, our machine learning models can fail to predict on the outcome variable. Therefore, when we look at the data that we have and we see that there are a few missing values in the feature market category, and we should take some steps to either deal with those missing values by uh, filling those missing values or also removing the feature. Here we see that most of the values in the market category are missing, which means that it will be a good option to remove that feature. But there are a few features such as engine horsepower and the engine cylinders, which only have one or two missing values, which means that we can actually add those missing values by taking the mean of the entire column or the median depending on the use case. And after that, we also group by and see what was the overall average price of cars over different years. And we see that cars in the year 2014 had the highest average price, followed by the other cars. This is very good to take a look at. And we also compare the average price of different cars based on whether they're manual or automatic, depending on the transmission types. We do find that most the price of the automated and automatic manual is the highest. Automated manual is nothing but having both the manual and automated drive. Similarly, take a look at the different car manufacturers and we try to see which of these are having the highest average price. And we see obviously that Bugatti has the highest average price, followed by Maybach, followed by Rolls-Royce and Lamborghini. And when we group based on the make and the engine horsepower, we also see that the Bugatti has the highest horsepower compared to the other cars. And we also take a look at McLaren, which is the second highest, and followed by Maybach, which is third. You can always take a look at all of these cars and then just see on Google and get a look at that. And based on the wheels that are taken, therefore we see that all-wheel drive cars typically tend to have higher price compared to the rear-wheel drive or the front-wheel drive. And when we look at the feature called popularity, which will give us how popular a given car is, we take the average value of those popularity values, and then we see that Ford is the most popular, followed by BMW, followed by Audi. And this is a scatter plot between highway mileage and city mileage. We see that both are quite similar. Highway mileage is quite similar to the city mileage, and that's why we see an almost linear relationship. Similarly, we also see the same here. This was just inverted, and this is a box plot which gives us the presence of outliers in the data. And these are all the outliers in the highway mileage. A car cannot have more than 100 mpg, right? Therefore, these are all some outliers which we have to remove in the data, which we do in this. And similarly, we take a look at the popularity and the engine horsepower. Generally, we assume that if a car has a higher horsepower, it is popular, but it might not be true always, as we have seen that Ford cars are usually having the highest popularity compared to Bugatti or many other top brands, right? Therefore, we do not find any linear relationship, and therefore there is no like a correlation between engine horsepower and popularity. Similarly, engine cylinders and popularity also looks like there is not a big strong relationship. And but we do have a relationship between engine cylinders and engine horsepower. Generally, if car has a lot of cylinders, the horsepower also would be higher, and vice versa. And we take a look at city mileage and highway mileage, and heat map is an interesting plot which will give us the correlation between various features. And based on that, we can say how much of a relation is city mileage in our case to popularity and a few others. And we check the null values, and similarly we plot a few things, and we manipulate the data, we convert the data, we have the entire data